We're going to play True Detective, Miss Christie's favorite thing. What we've got is this really nice Yamaha Neo euphonium compensating 4-valve. By the initial appearances, it looks like that it does not leak. However, the player says that all the slides pushed in, it plays in tune, and that should not be. A Yamaha should play sharp when all of the slides are pushed in. They're notoriously sharp in the partials. So that indicates that we have a leak. The first things that we tried were make sure that the pistons were in the correct spot. Guide was in the correct orientation. From there, we went and looked at solder joints to see if anything was noticeable. Everything looks good. I've got it on the Magnehelic and it looks good. I'm going to show you why that's false. There could be an obstruction in this main tube from here around to the belt. And if we have to use a borescope to go in and look, we will. If an object is inside the instrument, if something is stuck, but will still allow air to flow through, it will make the instrument play flat. Could be. The client also said that water was leaking out onto their right leg. So that would indicate that there may be water leaking from the number 4 piston, the compensating piston. It could be leaking out of a tuning slide. It could be a water key, but probably not one of the front-facing water keys. Now you're up to speed with where we're at. Bring the camera around, and we'll go from this angle. So what we've got going is I'm drawing air to the Magnehelic machine. It uses inches of water, so it's a quantifiable measurement. This is the same kind of apparatus that you would use in HVAC work. This is just an old school. Now they use digital, but it's a go, no-go. What we're doing is I'm running through all of the tubing except for what's coming out of the bell, this leg coming up. So I'm terminating here at the number 4 compensating slide, and then I'm going through all of this. And if we look at, I'll open this up, I'll push this water key sort of. 4 inches of water, which is about what I run my woodwinds at, and it pulls down. That is actually where my gauge zeroes out at. And it looks like everything is fine. But if we bump this up, let's say we take it to 6 inches of water. And we're going to watch it pull. So it has a leak somewhere. If we pull the tuning slide out, by running this form of a test, we can actually isolate each piston. So we'll draw on number 4, no movement, no leak. Number 3, no movement, no leak. Now, how do I know that that's, see, if I push the water key to open it up, and I push let's let it reset. If I want to engage a specific set of tubing in the piston, like I can push the 3rd valve, and the gauge is going to open and then it's going to draw. If I want to test the water key, I can push the 3rd valve, engage the water key, and then watch it fall back. And I can see that it's not leaking. Then we can come to number 2. We can check number 2. And number 2 is good. And we can come around to number 1. Number 1 is good. I'm going to open number 1 water key and let it fall. And number 1 is good. So what we've done is we've gone through and isolated each section of tubing, each piston with all of its respective tubes. If the pistons are worn and have a lot of blow-by, that will cause the instrument to play flat. It will also cause some other issues, other tuning issues. If there were a lack of grease on the instrument and the tubes were fit loose or they were worn, then that would suck air up. If the water key corks are worn, that would allow air to come by. If the springs are weak, that would allow air to come by. What we cannot see is we cannot test the porting. We can't actually see how things line up on the inside. But if it were off, it wouldn't necessarily cause a leak, but it would cause the instrument to play out of tune. So that for that we would run other tests. Right now we're trying to isolate and see if there's any leaks on the instrument. Let's test this tuning slide. Watching it fall. Oh! It came to rest. No good. We have a leak. This is some soapy H2O. We could have solder joints that are bad. Nothing there. This soapy water. Oh, there we go. That's the source of our leak. First feeling of it, I told Miss Kay that I felt like the spring tension was bad. The cork is pretty heavily worn, but I want to make sure that that nipple is not leaking as well. Let's see if I got a Duma Flitchy that size. We've put a stopper in. It falls to 0. Back on our soapy water trick. Confirm no leak. So the nipple is tight. It's our water key cork, and our spring was too weak. There you go. Some true detective work. Let's see if I was right. A wide open 6. Now we're going to draw all the air out. Look at that baby fall. That is good. No leak. Squirt a little bit of soapy water. No leak. Back to the horn. Slide is dry. Maybe we should put a little grease on it. Watch it fall. There it goes. Drop to 0. Push the number 4. So we're drawing through. It's good. It was that water key that was leaking. It's pretty cool. Being able to use quantifiable gauges on things and playing real life detective. That's what this job is. All right, thanks everybody. What I actually had planned for the focus of the video today was more on the journey of making my Dent machine into a workstation. I have the bell, flare, all set up to roll. I have a vise coming off of the side, which I have on the big tubes, and then if Miss K will come around, I also have set to take dents using the back. So I've got 2 dent rods and a flare roller in one setup that I can easily change. So I'm pretty happy about this. I'm tucked into my corner. Remember, we measured this area as to being like, I think it was 8 by 8. You want to do some dent work? Make quick work of this? We'll start back here. Ready? The key to using the dent machine is that you would have to do all of this work by hand in the first place. You can't just start on the roller. You actually have to get it semi back to round, like you've seen in a lot of the other videos that we've done. So you would have to do this work, this roughing out work. You would actually have to do this on one of the other vices. Or, like I would do, I would set these dent rods up in multiple vices within a step or two of each other. So I'm trying to get more efficient with the use of my space. I don't have a giant workshop here, and I really like the cozy feelings that I do have. But by doing this, I can basically rough out all of the dents where it will only take a little bit of burnishing work to put everything back. Another tip that you'll see is that I am not touching this lower tube at all. I am working from only this straight to this straight. By doing that, I'm not letting anything torque out of motion. If you were worried that you needed to work back here, you could solder a strut, a support arm, right there. So just like that, we have this arm ready to go. Then we can immediately put some grease on this side. Now we can work the dents here. Starting at the back and working our way down. I'm here. Now I'm here. Now I'm going to come across and do this section here. A question that often comes up is talking about work hardening the metal. And that's why you want to do hand work in the beginning to kind of rough this out into shape before using it, before rolling it. Because when you start rolling it like this, this is steel, this is steel, this is just a lonely piece of brass. And what will happen is it will work harden. You're having to squeeze it so hard to try to push these dents out that you do run a risk of that. You have to be careful. So by using hand work in the beginning to get everything roughed back to shape, there's a whole lot less that we're going to have to roll. And I can take areas that look like this, once I have them on a radius roller up here, that I will be able to blend that without as much pressure. So that's that branch, just that fast. We've got it roughed back to shape. It takes a little bit of time to set the machine up like this, but once you start getting down to the actual work, it goes pretty quick. This is our bell rim. This is pretty bad. Okay. We're going to start. I'm not even going to pound this rim. You'll notice that my arms are highly polished. There's basically no pressure. I can slide the bell on there. I basically have no pressure. What I'm using is I'm using my arms at an angle. So I want to kind of just let the brass tell me what it wants to do. So that's that big fold. And I'm just letting it go on its own. And then if I push against, without even using any real pressure, I can make the rim want to sit back down. Now we're back to our big fold. Now I'm going to start dialing in a little bit. Still haven't put any oil or grease on. Still not harming this lacquer. I'm not scratching this lacquer. I've got I'm high polished. Still not using heavy pressure. I'm working a specific punch. I'm going to dial it up a little bit. Work that punch. Remember how bad that was folded? She's coming back onto itself. Okay, if you look under here, on the other side, I have a very slow angle of the shoe of where I'm trying to put this. So it's good for getting from this side almost to the rim down into the flare portion. See that? I can get a pretty deep dive and then bring it out, and I can get pretty close to that edge, about an inch away. That's the effectiveness of this. My next stage for this is going to be to actually work all the way that last inch from the bell rim back. Now, I have a little bit of a punch dent here. I want to try to reach in and get before I reset. So I'm going to take this up as deep as I can get it. Okay, so we're out. Oh, okay, that was actually loose. I forgot to tighten that. Okay, so what we've got is all of that damage that we saw earlier is gone. I've taken care of it. That's where those big folds were. This is all straight. The lacquer is unharmed, what's left of the lacquer. If you're in a shop and you're doing play condition work, then this is something that happens that fast once you have it set up. Now let's finish this bell rim. Let's actually tighten the tool this time. Okay, now I want to dial up my angle. And as you can see that, I'm bringing that edge, the radius edge, all the way to the roller. That's what I want. The rod wasn't tight, and this wasn't tight, and we still got great results. So how about that? Okay, I'm just going to make a little bit of contact. You have to know how your tool is going to react. You have to be able to feel it. I used to do this all by hand. I would spend hours with a roller and hammers. when the manufacturer made the horn and they spun it on the lathe and they put it into this position of what we see here, when they did that, that was the new position for the brass. And that brass wants to go back to that spot, no matter how folded up it is. And there are times where you do have to use different methods to get it back there. But for even as damaged as what this was, okay, I got a little punch right there. I'm going to dial it in. I got a little punch right there. Back this off, move it over, dial it in. So I'm actually starting to make contact now, like real contact. Everything else I've done has just been loose. It's just been a loose roll. Got some little things right in here. Got a little thing right in there. Dial up a little bit. It takes so much less pressure than what you think it does. You're just moving brass. It's not steel. It acts totally different. If you watch some of the masters of using the English wheel with steel, and then you just adapt those principles over. But this machine has so much leverage in it. Boy, and I made a mess of some things. When I first started, I put marks and all kinds of things in. You just kind of have to get the hang of it. It takes a while. But that's it. There's our bell. This is where those big creases were. Right there. And the bell rim, it's basically straight. I mean, now we'll go in and I'll go level it out the rest of the way. Take the wire. There's a wire that's in these, and I'll lay all that back down. But that's my bell flare. Probably 95% done. All these different ways. I spend the time setting the machine up, and then it makes quick work of doing this stuff. It's pretty cool, I think. Well, all right, friends. Thanks for stopping by the shop today. This one came out great. Mag machine. You can get digital leak testers. This is an old one that I bought secondhand. Being able to put a quantifiable number on something really helps in our work. It's good to do things by feel, but it's also better or just as good to be able to see it on a gauge, to know, to verify. And that's what we're trying to do in these things. So this one is going to be good to go. The player is going to notice a remarkable difference in the horn on this. On the Dent machine stuff today, I hope you got something out of that. The Dent machine is such a useful tool. And I'm trying to think of it in more creative ways than what's just been handed down through time. So I'm trying to use it more because I'm trying to save my body. All right. Thanks, everybody. Appreciate the support. Y'all have a good one. I got to go get some work done. This is Wes Lee signing out.